Okay, so get this. You can actually teach a computer to predict things like, will you click on an ad or how much a house will sell for? It's kind of crazy.
Yeah.
It's the power of machine learning, and that's what we're breaking down in this deep dive.
Absolutely.
Starting from scratch.
From the beginning.
No fancy jargon, I promise.
Exactly.
We're going to make this super accessible.
Yeah, think of it like you're giving the computer a ton of data, and it figures out the patterns all on its own.
So instead of programming every single step, we're letting the computer learn from experience.
It's a bit like teaching a kid to ride a bike. You can explain it all you want, but they really learn by doing right.
Oh, that's a good analogy.
Yeah.
So where do we even begin with this?
Well, our source material jumps right into a simple example,
Okay.
predicting house prices.
Okay.
So imagine you have a bunch of data on houses, things like size, location, number of bedrooms.
Right.
You feed all that to a computer, and it can actually learn to predict how much a new house will sell for.
Wait, so just by looking at data from past sales, a computer can figure out what drives the price?
Yeah, it's not magic, but it's pretty close.
Wild.
Now, there are a few different ways computers can learn.
Okay.
Think of it like different learning styles for humans.
Okay.
Our source material breaks it down into 3 main types:
Right.
supervised learning, unsupervised learning, and reinforcement learning.
Okay, let's unpack these one by one. So what's supervised learning all about?
So imagine you're teaching a kid to recognize different fruits.
Oh.
You show them an apple and say, this is an apple.
Uh-huh.
Then you show them an orange and say, this is an orange.
Got it.
That's essentially supervised learning.
Okay.
You're giving the computer labeled data. You already know the answers.
Okay.
And it learns by matching patterns.
So it's like giving the computer a bunch of flashcards with pictures and labels.
Exactly. Now, unsupervised learning is more like giving the kid a big bowl of fruit salad
Okay.
and saying, figure out how to sort this.
Oh.
They have to find the patterns themselves without any labels.
So in unsupervised learning, the computer is more like a detective trying to uncover hidden relationships in the data.
Spot on. And finally, we have reinforcement learning. This one's all about learning through trial and error.
Okay.
It's like teaching a dog a new trick reward. Good behavior, discourage bad behavior.
So the computer's experimenting, getting feedback, and adjusting its strategy to achieve a specific goal.
You gotta think of those self-driving cars. They're using reinforcement learning to navigate roads and make decisions based on the feedback they get from their sensors and surroundings.
Wow, that's seriously impressive. Okay, so you've got supervised learning for learning from labeled data, unsupervised learning for uncovering hidden patterns, and reinforcement learning for learning through trial and error.
Those are the foundations. Once you get these, you've unlocked the basic logic behind how machines actually learn.
But how do we actually build these learning machines? Like, what are the key ingredients?
Our source material uses a brilliant analogy, baking a cake.
I love a good analogy.
Yeah.
Okay.
To bake a cake, you need a recipe, ingredients, and an oven, right?
Okay, I'm with you so far. I'm loving this analogy already.
Yeah.
So what's the recipe in the world of machine learning?
The recipe is what we call the model.
Okay.
It's the algorithm or set of rules that the computer follows to learn from the data.
Okay.
Different models are suited for different tasks, just like different cake recipes give you different cakes.
Gotcha. So the model is like the blueprint for our learning machine.
Yeah,
What about the ingredients?
that's where data comes in.
Okay.
Data is the raw information that we feed into the model.
Okay.
It could be anything from text and numbers to images and sounds.
Right.
The quality and type of data we use will directly affect how well our model learns.
So it's kind of like garbage in, garbage out, right?
Exactly.
If we feed the model bad data, we'll get bad results.
Exactly. And within that data, we have specific pieces of information called features.
Okay.
These are the characteristics that the model uses to make predictions.
Okay.
Think back to our house price example. Features would be things like size, location, number of bedrooms.
So features are like the individual clues that help the model solve the puzzle.
That's a great way to put it. Now we've got our recipe, our ingredients, and our clues. What's the oven in this analogy?
I'm guessing that's where we actually bake the cake, or in this case, train the model.
You nailed it. Training is the process of feeding the data into the model and letting it learn the relationships between the features and the outcome we're trying to predict.
Okay.
It's like baking the cake in the oven. The raw ingredients transform into something delicious.
So we're essentially teaching the model to make connections and predictions based on the patterns it finds in the data.
That's the heart of machine learning. And once the model is trained, we can use it to make predictions on new unseen data. It's like using our cake recipe to bake a whole new cake.
This is all starting to click. So we've got the model, the recipe, the data, the ingredients, the features, the clues, and the training process, the oven.
Yeah,
These are the building blocks of any machine learning project.
absolutely. You've just demystified the core components of how machines actually learn.
Now let's get our hands dirty and see how all this translates into real code.
Here's where it gets really interesting.
So our source dives into Python for this example. Is that pretty standard for machine learning?
Python is definitely the favorite, and for good reason.
Okay.
Think of it like this. You wouldn't use a hammer to sew a button, right?
Right.
You choose the right tool for the job. Python has all these amazing tools, or libraries as we call them,
Okay.
that are specifically built for machine learning.
So these libraries make it easier to work with the data and build models.
They're like pre-made building blocks. Instead of writing every bit of code yourself, you can use these libraries to do the heavy lifting.
Okay.
Our source mentions a few key ones: NumPy, Pandas, Scikit-learn, and Matplotlib. Just knowing these names gives you a sense of the powerful resources you have in Python.
That's helpful, but I'm still a bit hazy on how it all comes together. Can we walk through that house price prediction example from the source material?
Sure.
I think seeing it in action might make it clearer.
Let's do it.
Okay.
Imagine you're looking at a simple spreadsheet. You've got a column for house sizes and a column for their prices. That's your data.
Okay.
The first step is to load this data into Python using the Pandas library.
Okay.
Pandas is great for working with data that's organized in rows and columns like you'd see in a spreadsheet.
So we're essentially importing our data into Python so we can start analyzing it.
Exactly. And one of the best ways to understand data is to visualize it.
Okay.
Our source uses a scatter plot for this example.
Right.
It's a simple graph that plots each house on a grid with size on one axis and price on the other.
I remember seeing that it showed a pretty clear trend. The bigger the house, the higher the price.
Yeah, that visual representation is key. It helps you spot patterns and get a feel for the relationship between the features,
Okay.
in this case size, and the target variable, which is the price.
Right.
Now we get to the fun part, building the model.
This is where we choose our recipe for the learning machine, right?
Exactly. For this simple example, our source uses a linear regression model from Scikit-learn. Linear regression is basically finding the best fitting straight line through all those data points on our scatter plot.
So the model is trying to draw a line that captures the relationship between house size and price as accurately as possible.
You got it. This line becomes the model's prediction tool.
Okay.
You feed it a new house size and it tells you the predicted price based on where that size falls on the line.
That makes sense. So during training, the model is basically figuring out the equation for that line, right?
That's a great way to think about it. The training process involves finding the optimal slope and intercept for that line to minimize the error between the predicted prices and the actual prices from the data.
It's amazing how something as simple as a straight line can be so powerful. But I have a question. What if the relationship between size and price isn't perfectly straight? What if there are other factors at play?
Yeah, that's where things get more complex and you might need more sophisticated models.
Okay.
But for many real-world scenarios, a simple linear regression model can provide surprisingly accurate predictions.
I'm starting to see the real-world potential here. But our source also mentions a few other concepts. Model evaluation and feature scaling. What are those all about?
So model evaluation is like giving your model a report card.
Okay.
You need ways to measure how well it's performing, how accurate its predictions are. There are different metrics you can use to assess the model's performance. But the key is to understand that evaluation is an essential part of the machine learning process.
So it's like checking your work to make sure the model is actually learning and making reliable predictions.
Precisely. Now, feature scaling is a bit more technical, but it's all about making sure the features you use are on a level playing field.
Can you elaborate on that?
Imagine some features are shouting their information while others are whispering. Feature scaling. Make sure every feature speaks at the same volume so the model can hear them all clearly and give them equal weight.
That's a fantastic analogy. I can see how that would improve the model's accuracy.
Yeah, it's one of those behind-the-scenes tricks that can make a big difference. Our source uses an example of standardization, which basically centers all the features around 0 and scales them to have a similar range.
So feature scaling is kind of like prepping the data before we feed it to the model to ensure everything is standardized and fair.
You're catching on quick. It's all about setting the stage for optimal model performance.
This house price example has been incredibly helpful. It's amazing to see how the abstract concepts we discussed earlier actually translate into code and tangible results.
Even with the simple example, you can start to grasp the power of machine learning. But what's even more exciting is that this is just the tip of the iceberg.
I can only imagine the possibilities with more complex models and larger data sets.
That's where the real magic happens.
Okay, so in this deep dive, we started by demystifying machine learning.
Great.
You learned that it's all about teaching computers to learn from data without having to program every single step.
Absolutely.
We explored the three main types of machine learning: supervised learning, unsupervised learning, and reinforcement learning.
And you even got a taste of how those concepts translate into real-world applications.
And we used the baking analogy to break down the core components of a machine learning project: the model, the data, the features, and the training process.
Yeah, and we walked through a simple example of predicting house prices using Python and linear regression.
Right, and that example really helped to solidify those core concepts and showed how a machine learning model can be trained to make predictions on new data.
Yeah, it's fascinating to think that even with a basic understanding of these fundamentals, you can start to grasp how machine learning is being used all around you.
It's really changing the world as we know it.
Absolutely, from personalized recommendations on your favorite streaming platforms to the algorithms that power self-driving cars, machine learning is everywhere.
It is. And as this technology continues to advance, its impact on our lives will only become more profound.
That's why it's so important to understand the fundamentals, even if you're not a programmer or a data scientist.
Hmm.
Knowing how machine learning works empowers you to engage with this technology in a more informed and critical way.
Definitely helps you see the possibilities and the potential pitfalls.
Exactly. Now, if you're feeling inspired to dive deeper into the world of machine learning and explore more complex concepts, there are tons of resources available online and in libraries. You can also connect with experts and mentors who can guide you on your journey.
And if you're looking for personalized one-on-one training and consultancy, I highly recommend checking out Scogini.com. They offer fantastic programs to help you master machine learning and unlock its full potential.
It's a great resource for anyone who's serious about taking their machine learning skills to the next level.
Well, that wraps up our deep dive into machine learning for beginners. We hope this journey has sparked your curiosity and given you a solid foundation to build upon.
Remember, the world of machine learning is vast and constantly evolving, so
Stay curious, keep exploring, and who knows, maybe one day you'll be the one building those groundbreaking machine learning applications that shape the future.
until next time, happy